Hi all, the purpose of this video is to go over current carrying wires and the Lorentz force. So our learning goals and objectives are to one, know the Lorentz force for current carrying wires and how to solve for forces on those wires. And the second is to know the other right hand rule that determines the direction of the B field due to a current carrying wire. Alright, sorry about that. So if we have current I, then the way we solve for the B field is to, one, curl fingers of right hand. So you're just going to take your hand, you're going to curl your fingers. The second is make sure your thumb's up. So thumbs up, because physics is thumbs up. 3, point thumb in direction of B field. And 4, your curled, point thumb in the direction of the current. My bad. I apologize. Direction of current. And now fingers give B field direction. Okay, so if we did this here, we would curl our fingers, we'd point our thumb the direction of the current, so it's towards the bottom of the screen. And now if we look at where our fingers are curled and we draw the B field, then we see as we rotate our hand that we're going to have B field on both sides. So there's a B field, and then on this side we're going to have it so that the B field is coming out of the screen at you, so that gets a dot, like it's an arrow coming at you. And then on this side the B field is into the screen, so it gets an X. Perfect. So now what we need to do is talk about the Lorentz force for current carrying wire. That's just going to be the current I times the length vector L crossed into B. So this length vector would just be whatever length of wire we're looking at of L, and then its direction is given by the direction of the current. So what we can do is we can add in a second current carrying wire. It will be in the same direction. It'll also be I, and we can draw the magnetic field still from this first one, still in this direction, so the spacing should be a little bit different, but anyways. So what we're going to do is we're going to determine the direction of the force on this second wire. So we can label this wire 1 and wire 2. So the force on wire 2, given that wire 1 is producing a magnetic field. So what we do is we align our fingers in the direction of the current. So our fingers would be pointing towards the bottom of the screen. We're going to then rotate our hand and face our palm in the direction of the B field. So our palm should be facing into the screen, and then we're going to be able to shut our fingers and point in the direction of the B field. So okay, great. So our fingers can point in the direction of the B field, and then what you should see is that your thumb points inwards. So there is an attractive force, Fm. The Lorentz force is attractive between the two. Alright, thank you.